Yeah, I think so. Here's so like the person's here, the kite's up here, the string is a hypotenuse, and then the angle they're talking about is this angle.
Okay.
I think, and I'll erase this, but I think that's what they're talking about now. Okay. So it is asking. So I guess let's put everything that we know. Our h is 100, our dx over dt is 8, and our hypotenuse is 200.
Okay.
What we want to find is d theta over dt.
Okay. Yeah. This is theta.
So we know our hypotenuse, we know the adjacent side to the, or sorry, we know the opposite side to the angle is 100. So we'd have to use cosine here, I want to say. Yeah. So hypotenuse. Or sorry, sine, sorry. Sine, opposite of hypotenuse.
What do they tell us?
They tell us dx over dt.
Dx dt. So that's the x is what you have to put the equation in terms of.
Right. So I had that thought, I guess. So like we could use tangent, and I would put it as a our height over x, which would be 100 over x. And then if we took the derivative of that, it'd be 8 feet per second. It would be dx over dt, but
Actually,
that doesn't
yeah.
give us the angle.
Yeah, actually, I do think this would work. We could do it this way. So, yeah, tangent theta. Yeah, because the whole goal is to relate theta to x, and this equation does that. But then there's going to be kind of something else to watch out for if you use this equation. All right, so let's stick with this. So then, what do you
Okay.
do?
So now we have to derive it.
Okay.
So the derivative of theta is secant squared theta. Or sorry, of tan theta is secant squared theta. I think
Wait, say it again.
the derivative of tangent is secant squared.
Yeah, secant squared. Okay.
Okay.
How do you differentiate
Or
when you have an
100,
x in the denominator?
turn it into a fraction or into an exponent. So like negative
Yeah, exponent exactly. What with
x to the
x?
negative x to the negative wouldn't be 1.
Why not?
Actually, would it be? Yeah, it would be x to the negative 1.
Yeah, because negative flips it, and there's no exponent with the x, so that means it's just an exponent of 1. Okay, and then yeah, if you differentiate that, what do you get?
Right. So you bring down the negative 1, it'd be negative 100, and then you have to turn it into negative x to the negative 2. X to the negative 2. And then x to the negative 2 is just 1 over x squared.
Okay.
Squared. Okay. So secant squared theta is equal to 100 over x squared. So that x squared, do we still need to differentiate? So multiply by the derivative of x? Or no?
Yeah, so remember, what are you differentiating with respect to?
Time.
T, right? So how do we treat theta and x?
As functions of time.
Okay, yeah, so if they're functions, then what rule do you have to apply? Well, this
Product
would be
rule.
the out. Yeah, well, this if you think of theta as a function, then secant squared is a function, and then theta is inside, but theta is also a
Okay.
function.
That makes
So,
sense. Okay. That makes sense. But is there anything we have to do with dx over dt? Because
well, x is also a function of t,
function.
so x is inside. So 100 over
Oh,
100
100.
over x is the outside function, but then x over t is itself is an inner function.
Okay, that makes sense. So it'd be secant squared times d theta dt and negative 100 over x squared times dx dt.
Yeah, chain rule, right?
Okay, that makes sense now.
Slash implicit differentiation kind of.
Yeah. I could see like the dx dt. I didn't see the d theta dt. But that makes sense.
Okay.
So we want to get d theta over dt on its own.
Yeah.
So we divide it by secant squared theta on both sides.
Okay.
One over secant squared theta. Shoot, is it cosine squared theta? That's one over secant squared theta.
Yeah, same thing, right? Reciprocal of reciprocal is the original.
Okay. Oh, I see where this is going now, I think. So we have a value for cosine squared theta and d theta at a certain point in time. Now, what do we do with an x? X, I suppose we can figure that out with Pythagorean theorem as well. Okay, so now we can start to try to plug stuff in. Our hypotenuse, so our r is going to be 200. And we need to figure out x in order to get cosine and x squared. So it's 100 squared plus b squared is equal to 200 squared. So let's see. X squared is 200 squared. Would it be x squared as the distance, or would it just be x?
Oh yeah, sorry. X just x.
Okay, so x squared is 200 squared minus 100 squared, I think.
Okay.
Yeah. So 200 squared is 40,000, I think. And 100 squared is 10,000. So x squared is 30,000. So x is the square root of 30,000. And I imagine there's some way to simplify that, but I think that'll be fine. Okay, well now we can just start plugging in. So x squared is square root of 30,000. Squared is 30,000. Cosine squared is square root of 30,000 over 200.
Square root of 30,000.
30,000 over 200, and then just that squared, right? Yeah. And then times
over 200 squared. Okay.
Yeah. And then dx over dt is 8.
Okay.
And then we would just do that math. That would be our d theta over dt.
Yeah, I think that should be good. One thing to note is, yeah, so this approach works, but what do you notice about the ratio of these sides? Like if this side is 100 and this side's 200, what does that remind you of? Are any triangles where the hypotenuse is double one of the legs?
Square root of 3?
Yeah, root 3. 1, 2, root 3.
Yeah.
You know what kind of triangle this is?
Is that a 36? No, it's not a 30, 60, 90. It is.
30, 60, 90.
Oh, okay.
Yeah, so then if you remember that, you could easily figure out that theta is 30. You can plug in
30
theta 30 for theta. This would be root 100 root 3, right? And then, yeah, if you plug in, you use those numbers, it should end up being the same thing.